Hello, let's evaluate this integral. I equal to integral minus infinity to plus infinity gamma of 1 plus I x square into gamma of 1 minus I x square dx. Right? As you know, gamma of 1 plus x is x into gamma of x. Then I will be integral minus infinity to plus infinity gamma of 1 plus I x square will be I x square into gamma of I x square into gamma of 1 minus I x square dx. Right? Then this will be, as you can see here, this is gamma of I x square into gamma of 1 minus I x square by Euler diffraction formula. Gamma of x into gamma of 1 minus x equal to pi by sine of pi x. Then this will be integral minus infinity to plus infinity I x square into pi by sine of pi x, right? This is pi. Here x is I x square dx. So finally here I equal to integral minus infinity to plus infinity I x square into, let pi will come out, right, because it's constant. Then it will be by sine of I pi x square into dx. As you know, sine I pi x can be written as, in terms of hyperbolic functions, it will be pi into integral minus infinity to plus infinity I x square by I sine h of pi x square dx. This I will get cancelled. So I is pi into integral minus infinity to plus infinity x square by sine h of pi x square dx. As you know, the function sine x is, so sine hyperbolic function of x is e power x plus e power minus x by 2. Then this can be written as pi into integral minus infinity to plus infinity x square by e power, here x is pi x square, right? Pi x square, sorry, here the sign for sine hyperbolic function is minus, right? E power pi x square minus e power minus pi x square by 2, then 2 will come up. So I is, write it down again, integral minus infinity to plus infinity, bring the 2 out of the integral, then this will be x square by e power pi x square minus e power minus pi x square dx. So let's try one thing here. As you can see here, this function is even function, right? If you substitute x tends to minus x, then it will be the same. So you can write it as I equal to 4 pi into integral 0 to infinity x square by e power pi x square minus e power minus pi x square dx. Right? So let's do one thing here. Integral 0 to infinity. We will try to write it in the form of exponentials. So let's multiply both numerator and denominator with e power minus pi x square. X square into e power minus pi x square by e power minus pi x square into e power pi x square minus e power minus pi x square into dx. So I will be 4 pi into integral 0 to infinity x square into e power minus pi x square by, this will be 1 minus e power minus 2 pi x square dx, right? So let's simplify these terms first. I mean e power minus pi x square by 1 minus e power minus 2 pi x square. Let's try to write it in the form of summation. E power minus pi x square, this will be 1 minus e power minus 2 pi x square whole power minus 1. 1 minus x whole power minus 1 form is 1 plus x square, right? And so on. This will be e power minus pi x square into 1 plus e power minus 2 pi x square. Then next term will be x square term, right? E power minus 4 pi x square. Then this next term will be e power minus 8 pi x square plus and so on. After multiplying with this term, this will be e power minus pi x square plus e power minus 3 pi x square plus e power minus 5 pi x square and plus so on. So you can write this as e power minus pi x square by 1 minus e power minus 2 pi x square, as you can see here in the exponential parts everything are in the odd number form. So e power minus of pi x square into 2n minus 1 and summation n equal to, if n equal to 1 it will be 2 into 1 minus 1 and it will be e power minus pi x square. If n equal to 2, 2 2 is 4 minus 1 3 e power minus 3 pi x square, right? This is how you can write the summation form. Then I is substitute this in equation 1. In equation n, from 1 I will be 4 pi into integral 0 to infinity x square into, this term is summation n equal to 1 to infinity e power minus pi x square into 2n minus 1, right, into dx. Then let's make some simplifications here. I mean just bring this summation out of the integral. Summation n equal to 1 to infinity integral 0 to infinity. Let's do one thing here. If you want to make this as a full differentiation, I mean d of something e power minus pi x square term, so let's multiply. There is a pi term here, right? There is a, let's do it here. Let's just 2 pi and bring 2 factorial inside. This is, here there is this x square, right? Multiply twice because there is a 2 factorial, 1 factorial inside. 2x into e power minus pi into 2n minus 1 into x square dx, right? Then let's multiply minus symbol here. You'll come to know why we have multiplied these numbers, because when we differentiate e power minus pi 2n minus 1 x square, right, then it will be, let's multiply, this is minus 2 into, right, minus 2 pi into summation n equal to 1 to 2 pi summation n equal to 1 to infinity 0 to infinity x into minus 2x into, let's multiply and divide with 2n minus 1. by 2n minus 1 into e power minus pi into 2n minus 1 x square into dx. So this I will be minus 2. Sorry, this there is n dependency, right? We need to write inside of this minus 2 into summation n equal to 1 to infinity 1 by 2n minus 1 integral 0 to infinity x into, you are bringing this pi factor inside, x into minus 2x into 2n minus 1 into pi e power minus pi into 2n minus 1 x square into dx. So as you can see here, this part, clearly observe this part, but let's try to differentiate this e power minus pi into 2n minus 1 x square, right? This will be e power minus pi into 2n minus 1 x square into minus pi into 2n minus 1 into 2x, right? That is minus 2x into 2n minus 1 into pi into e power minus pi 2n minus 1 into x square. So this I can be written as minus 2 into summation n equal to 1 to infinity 1 by 2n minus 1 into integral 0 to infinity x into d of e power minus pi into 2n minus 1 x square. Fine. Now you can apply u integral uv dash form. Then this will be I equal to minus 2 into summation n equal to 1 to infinity 1 by 2n minus 1. This will be uv, right? Uv is u is x. This will be e power minus pi into 2n minus 1 x square. This is 0 to infinity minus of u dash into v. We write this will be e power minus pi into 2n minus 1 x square, right? This will be 2n minus 1 x square. This is u dash into v, right? This is v, then u dash is it will be 1 dx 0 to infinity. So I is minus 2 into summation n equal to 1 to infinity 1 by 2n minus 1 into, as you can see, when x is infinity, e power minus infinity square, then it will become 0. When x equal to 0, 0 into something, it will be 0. That means this term will not contribute. Then this is minus integral 0 to infinity e power minus pi 2n minus 1 into x square dx. So I will be 0 minus 0 will be 0. Then 0 minus this term, minus minus will get plus 2 into summation n equal to 1 to infinity 1 by 2n minus 1 into integral 0 to infinity e power minus pi into 2n minus 1 x square into dx. So this is in the form of Gaussian integral form, which is integral minus infinity to plus infinity e power minus alpha x square dx is root of pi by alpha. In our case, we have, because this is a even function, then integral 0 to infinity e power minus alpha x square dx will be half of root of pi by alpha, right? Then this will be 2 summation n equal to 1 to infinity 1 by 2n minus 1 into 1 by 2 into root of pi by, here alpha is pi into 2n minus 1, right? Pi will get cancelled, 2 will get cancelled. Then I will be summation n equal to 1 to infinity 1 by 2n minus 1 into root 2n minus 1, which will be summation n equal to 1 to infinity 1 by 2n minus 1 whole power 3 by 2. If you want to make the summation from n equal to 0, then this will be summation n equal to 0 to infinity, then this becomes 2n plus 1, right? Whole power 3 by 2. So to make it look like a zeta function, you need to take common from here 2 factor summation n equal to 0 to infinity 1 by 2 power 3 by 2 into n plus half into 3 by 2. So I will be 1 by 2 power 3 by 2, you can write it as 2 root 2, right? 2 into 1 plus half, which 2 power 3 by 2, right? Then this will be summation n equal to 0 to infinity 1 by n plus half into 3 by 2. From the form, as you know, this Riemann zeta function summation n equal to 0 to infinity 1 by n plus a whole power s is Riemann zeta function of s comma a. In our case, I is 1 by 2 root 2 into Riemann zeta function of, here s is 3 by 2 and a is half. So finally our solution is integral minus infinity to plus infinity gamma of 1 plus ix square into gamma of 1 minus ix square dx is the Riemann zeta function of 3 by 2 comma 1 by 2 by 2 root